Yeah. Look at this question, all of you. Please stop working. Look at this question. The inside perimeter of a race track is 340 meters. The diagram of the race track is given in the question. Now, these are the, I haven't still completed the diagram of the racetrack. I just want to explain as I draw. So you can see here, these 4 line segments are of equal lengths and they are parallel to one another. These 4 line segments are of equal lengths and they are parallel to one another. Now the ends are semicircles. The ends of the racetrack are semicircles. The ends are semicircles. The ends are semicircles. Please excuse my diagram. Okay. So I showed you the 4 straight edges of the racetrack. 4 straight parallel edges. Parallel edges. Okay. Now, of these 4 straight parallel edges, these are called the inner edges. This one and this one. They are the inner edges. Inner parallel edges. Inner parallel edges. And these 2 are called the outer parallel edges. Outer parallel edges. Outer parallel edges. So the racetrack consists of 4 straight parallel edges. The inner ones are called the inner parallel edges. And the 2 outer ones are called the outer parallel edges. The ends are semicircles. The ends are semicircles. The ends are semicircles. All right. Now let's read. The inside perimeter of a racetrack is 340 meters. Now, one more thing, children. So there are there are 4 semicircles actually, 2 on either sides. There are 2 semicircles on either sides, the left and the right side, 2 semicircles. In all, there are 4 semicircles. But these 2 have the same radius. This one and this one, they'll have the same radius. So there is one, inner radius or the small r and one outer radius or the capital R. There will be 2 different radii here. Okay, so the radius of the inner semicircle, these are the inner semicircles. This one and this one are the inner semicircles. Okay, of radius small letter r. And this one, and this one are the outer semicircles whose radius is capital R. Capital R. Now this one is called the width of the track. This one is called the width of the track. This is the width of the track. The track has a uniform width everywhere. The track has a uniform width everywhere. This is the width of the track. Width of the track. Where the athletes run, you know. Where the athletes run, that one is the width of the track. This middle portion, in this portion, friends and fans, if it is sports day in your school, maybe the teachers have assembled here, the participants will stand here. And when a particular race is going on, then the participants are running here. The participants of that race, they are running here in this track. Here is where the other participants and the teachers are here, standing along with the PT master. So that's what you see here in this diagram. This is the thickness of the, this one is the thickness of the width of the track. The width of the track. This one is the width of the track, and the width of the track is uniform. And the width of the track is given to be 7 meters. So if the inner radius is r, we know that the inner radius plus the thickness or the width of the track is equal to the outer radius. Is equal to the outer radius. Correct? All right. So the inside perimeter, so there are 4 straight line segments and two different semicircles of 2 different radii, one small r, one capital R. Now the perimeter of the inside perimeter of the racetrack is given, that is this one, the perimeter of this one. See here, I'm going along the boundary. The length of this line segment plus the length of this semicircle plus the length of this line segment plus the length of the semicircle. All this put together is 340. The inside perimeter. See which one is the outside perimeter? This one. The length of this line segment plus the length of this semicircle plus the length of this line segment plus the length of this semicircle will be the outer perimeter. So that there are 2 different perimeters here. Inside perimeter, outside perimeter. Inside perimeter is the length of the boundary. So I'm showing you the inside perimeter once again. This length, see here, from here, this length, which is 60 meters, plus the length of the semicircle, which is pi r. The length of a circle is 2 pi r. Semicircle is pi r. So it is 60 plus pi r plus 60 plus pi r is equal to 340. So let's start working. Inside perimeter is equal to 340 meters. So inside perimeter is actually this one. This one is the inside perimeter. From here to here it is 60. From here to here it is 60. This one is pi smaller. This one is also pi smaller because circle is 2 pi r. Half of it is pi r. So inside perimeter is 60 plus pi r plus 60 plus pi r is equal to 340. So 120 plus 2 pi r is equal to 340. 2 pi r is equal to 340 minus 120, 220. So 2 into 22 by 7 into r is equal to 220. R is equal to 220. 2 will become 1 by 2 on the other side. 22 by 7 becomes 7 by 22 on the other side. So 22 ones are 22 tens are. 2 ones are 2 fives are. So small r is equal to 35 meters. Now we know the width. The width of the track is 7 meters. Therefore, capital R is equal to small r plus W, which is equal to 35 plus 7, 42 meters. So we found the radius of the inner semicircle and the outer semicircle. Now let's read ahead. We use the inside perimeter 340 meters to find the inner radius plus the width of the track gives us the outer radius. Now if the track is 7 meters wide, find the area of the track. The question is to find the area of the track. But to find the area, we need to find the inner radius and the outer radius. Find the area of the track. Also find the outer perimeter of the track. So how do we find the area of the track? See here, what makes the area of the track? This one is the area of the track. This is the track. Okay, can you see? This one. We need to find the area of this region, and this one is a semicircular ring. This one is also a semicircular ring. Semicircular ring. We know what a circular ring is here. This one is a circular ring. This one is a circular ring. This region. This one is a circular ring. We find this half. We find this half on one end. And we find this half On the other end, So see here, these two put together, this end and this end, when you put them together, they'll make a circular ring like this region. They'll make this one. The ends put together will make one, each end, this portion in each end, this portion, this one is a semicircular ring. This one is also a semicircular ring. When you put these two together, it look like this. One circular ring whose area is given by pi capital R square minus small r square. Then, so this we found. This one and this one together is pi capital R square minus small r square. And now this one is a rectangle. This one is also a rectangle. Now the area of this rectangle will be L into B. This is 60. And the width of the track is 7. This is 7. So the area of one rectangle is 60 into 7 because this one is 60. And this width is 7. Similarly, for this rectangle, length is 60 and the width is 7. So the track is made up of the track. The track is the portion where the athletes run, not the inside portion. See, this one, when you're asked to find the area of the track, you're not asked to find the area of this portion, children. Only the shaded region where the athletes run. Okay, so the shaded region here is made up of two rectangles and two semicircular rings. Both put together will make one circular ring. So you should find the area of two rectangles and one circular ring and to find the area of the track. So now let's find the area of one circular ring. Area of, we can say area of two semicircular rings is equal to area of one circular ring, which is equal to pi capital R square minus small r square, which is equal to 22 by 7 into capital R is 42. So 42 square minus 35 square. So you can use the formula a square minus b square is equal to a plus b into a minus b. A plus b, 42 plus 35 into a minus b, 42 minus 35. 22 by 7 into 77 into 7. So 7 and 7 gets cancelled using the calculator. 22 into 77. I'm getting 1694. 1694 meter square. Now, area of the rectangles. Area of two rectangles is equal to one rectangle is L into B. You want 2. So 2 into L into B. So 2 into length 60, breadth 7. So this will be 120 into 7. 12 sevens are 84. 840 meters square. You can just call this 2. You can call this 1. So area of the track is equal to 1 plus 2. 1 plus 2, which is 1694 plus 840. And my calculator says 2534 meter square. Now next is to find the outside perimeter, the outer perimeter. The outer perimeter is again this one only. On the outside, this one. On the outside, this one. This one is the outer perimeter. So outer perimeter is equal to 60 plus pi capital R, because the length of this semicircle is half of 2 pi R, but R is capital R because outside semicircle it is. capital R. See, for inside perimeter, we use small r. See, for inside perimeter, we said 60 plus pi small r plus 60 plus pi small r for inside perimeter. Because for inside perimeter, it is the inner semicircle. It's the inner semicircle. For outside perimeter, it's the outer semicircle. The outer semicircle. So the outer perimeter will be 60. This is 60 plus this one is pi capital R. This is 60 plus again pi capital R plus pi capital R plus 60 plus pi capital R. 120 plus 2 pi R. 120 plus 2 into 22 by 7 into R. What was R? Outer R 42. So 7 ones are 7 6 are 120 plus 12 into 22. 264, which is 384 meters square. Oh, not meters square, sorry, meters. It is perimeter, no? So, meter. Write down, children. Quickly copy the question and write the answer. So this language you should understand. That is, they'll use straight parallel edges, inner parallel edges, outer parallel edges. Children, I'm going to wait for you to finish this. Only then we'll go to the next one. But just take screenshots because each of you will be working on a different pace. So just take pictures so that you can, like you don't have to wait for me to take you to the next slide. Take pictures, children. Done?
Yes, ma'am. Yes, ma'am.
Okay. Yeah, this is second one.
Taken, ma'am.
Yeah.
One minute, can I go back?
Sure, sure.
Yes,
Done?
ma'am.
Yeah. Done, children?
Yes, ma'am.
Yeah. Yeah, that's all. Yeah, now you can all write in your own pace. Completed the earlier one, children? All of you?
Yes, ma'am.
All right, good. See the next one. Two circles touch externally. So touching circles are different from intersecting circles. Circles need not have any point in common. So like, see like this. These two circles have no point in common. These two circles have no point in common. Now, touching circles have exactly one point in common. Touching circles have exactly one point in common. Two circles can touch each other internally or externally. Internally like this. Like this. Two circles can touch each other internally like this. They can touch each other externally like this. Sorry, not use. One second. Becomes intersecting. Like this. Touching circles, they have only one point in common. Only one point in common. Intersecting circles have 2 points in common. Intersecting circles have 2 points in common. All right, so these are touching circles. Here the two circles touch each other internally. Here the two circles touch each other externally. Touching circles have only one point in common. These represent intersecting circles. Intersecting circles have 2 points in common. So here this question talks about touching circles, not intersecting circles. Two circles touch externally. Externally, so not this case. Internally is this one like this. Two circles touch externally. The sum of their areas. So area of circle 1 plus area of circle 2 is 130 pi. And the distance between their centers is 14 centimeters. The distance between their centers. What is the distance between their centers? R plus R. Distance between their centers. Distance between their centers is equal to 14. That means R plus R is equal to 14. Am I right, children?
Yes, ma'am.
So symbolic in words, distance between their centers is 14. So how do you convert this to an equation using variables? Small r plus capital R is equal to 14. Now, at this point, you might not know that you should write capital R is equal to 14 minus R. So you can even stop here because you don't know that you have to write this. No, so you can just stop here. Now use the other information. The sum of their areas is 130 pi. That means pi r squared plus pi r squared is equal to 130 pi. Pi common, pi gets cancelled on both the sides. And now you have r squared plus r squared is equal to 130. So you have to substitute. So you can either replace small r with 14 minus capital R or capital R with 14 minus small r. Anything. Anything. So then you get a quadratic equation. You can write small r is equal to small r. You can also write small r is equal to 14 minus capital R or capital R is equal to 14 minus small r. Anything. Now substitute here. So you'll get a quadratic equation in R. Please solve and tell me the values of R, children. Take down the question, draw the diagram.
Ma'am, I'm getting 3 and 11, ma'am.
3 and
11.
okay. So now both are positive. So you have to go with both. So if the radius of one circle is 3, then the other one is 11. If the first one is 11, the second one is 3. If the first one is 3, then the second one is 11. 3 and 11 should be right.
I got 3 and 11 as well.
Very good. Okay. We'll do one thing, children, because now that I've used small and capital R, no, it might kind of, when you get a capital R, when you write capital R as 3, it might not, kind of look good. So you can just use R1 and R2. The working is the same. You can use R1 and R2. I'll just redo this. Let's say R1 plus R2 is equal to 14. So R1 is equal to 14 minus R2, or R2 is equal to 14 minus R1, whatever. Okay, so some of their areas. Distance between their centers is equal to 14, right? 14, yeah. So you can say R1 plus R2 is equal to 14. So R2 is equal to 14 minus R1. Then sum of the areas, sum of their areas is equal to 130 pi. So pi R1 square plus pi R2 square is equal to 130 pi. Pi common, R1 square plus R2 square is equal to 130 pi. Pi gets cancelled. So R1 square plus R2 is 14 minus R1. The whole square is equal to 130. So R1 square plus 196 minus 28 R1 plus R1 square is equal to 130. So what's the equation we get? Two R1 square minus 28 R1 and then 130 on the other side, right? So 66 plus 66. Am I right, children?
Yes, ma'am.
Is equal to 0. So dividing by 2 throughout, R1 square minus 14 R1 plus 33 is equal to 0. 11 3s are 33 minus 11 R1 minus 3 R1 plus 33 is equal to 0. R1 common, R1 minus 11 minus 3 R1 minus 11 is equal to 0. So R1 minus 11 into R1 minus 3 is equal to 0, which makes R1 11 or R1 is equal to 3. So now you can complete like this. If R1 is equal to 3, then R2 is equal to 14 minus 3, 11. If R1 is equal to 11, then R2 is equal to 14 minus 11, which is 3. I had used the variables smaller and capital R. So when we give an answer like R is 11 and this one is 3, we used to giving a bigger value for capital R and a smaller value for small r, right? So it might not kind of look good. So I said just change it to R1 and R2. That's all. The working is the same, but you can use R1 and R2 for a better presentation. Done, children? Shall we go to the next one?
Yes, ma'am.
Yes, ma'am.
Okay. So here we had to assume the radius to be R1 and R2. Distance between their centers, because they are touching externally, because they touch externally. The difference, the distance between their centers, the distance between these two is the sum of their radii. R1 plus R2 is equal to 14. And then the sum of their areas, pi R1 square plus pi R2 square is equal to 130 pi. So on working that and substituting, R1 in terms of R2 or R2 in terms of R1, you get a quadratic equation. Solve and get the two values and substitute again to get the final answer. Next one. So here the circles touch internally. All right. So here the circles touch internally. I have roughly marked, okay, rough diagram, and I've roughly marked the centers of the two circles. So this is the radius of the inner circle, children. This is the radius of the inner circle. And from here, this is the radius of the outer circle. Oh, sorry. This is the radius of the smaller circle, and this is the radius of the bigger circle. This one is the radius of the smaller circle. And this one is the radius of the bigger circle. So let the radius of the, or let the radii, okay, radius of the smaller circle be R1 and larger circle be R2. Let the radius of the smaller circle be R1, larger circle be R2. So now how do you express that, children? How do you express the distance between their centers?
R2 minus R1 is equal to 6.
Was that Navya?
Yes, ma'am.
Very good. All right. Good. So this will be R2 minus R1, because here what will be the distance between their centers? See here, children, this is the distance between their centers. This one is the distance between their centers. This one is the distance between their centers. Now listen to this. See here. What is this full thing? What is this full thing? R2. What is this one? R1. And what is this? The distance between their centers. So see here. Distance between, I'll just write this one for between, distance between the centers. See, children, distance between the centers. Can you see this? This one is the distance between the centers. Plus R1 is equal to R2, right? If it's difficult to understand, so you can just do it like this. See, I'll show you again. See here. This is the center of the smaller circle. This is the center of the bigger circle. This is the distance between the centers. That's what I've written here. Distance between the centers. Plus R1, which is the radius of the smaller circle. Distance between the centers plus R1 is what? Is this full thing? What is this full thing? R2, right? Is the radius of the bigger circle, R2. That's what I've written here. The distance between the centers plus R1 is equal to R2, the radius of the bigger circle. Now from this, what do you get? From this, what do you get? Distance between the centers. Distance between the centers is equal to R2 minus R1. You can write this directly. Just in case we didn't understand, this should help you. Okay, so we understand that R2 minus R1, the radius of the outer circle minus the radius of the inner circle, is equal to the distance between their centers. The distance between their centers is given by R2 minus R1, and that is 6. It's given in the question. The distance between their centers is 6 centimeters, which means R2 minus R1 is equal to 6. So you can write R2 is equal to R1 plus 6. Then the sum of their areas is 116 pi. Sum of their areas, sum of their areas is equal to 116 pi. So pi R1 square plus pi R2 square. Sum of their areas. Area of the smaller circle plus the area of the larger circle. Pi R1 square plus pi R2 square is equal to 116 pi. Pi common. R1 square plus R2 square is equal to 116 pi. Pi gets cancelled on both the sides. R2 is R1 plus 6. Yeah, work this.
Ma'am?
Yes.
Ma'am, I'm getting R1 4 centimeters and R2 10 centimeters.
You can't get both positive. Just check.
Ma'am, I got R1 as minus 10 and 4.
One positive, one negative, right?
Yes, ma'am, but minus 10 will be negative. Ma'am.
Yeah, that's what you should ignore that. Ignore the negative value because radius cannot be negative. Ignore the negative value. Take only the positive value.
Yes, ma'am. Then R2 will become 10.
What are the two values you've got for R2 or R1?
Ma'am, R1 is minus 10 and plus 4.
Okay,
Minus 10 is negative.
correct. So R1 is 4.
So R, and,
Yeah,
and R2 is 6 plus 10.
correct. Yes, you're right.
Yes, ma'am.
Very good. Yes.
Complete, ma'am.
Yeah. How much is this? 80, yeah? Please check your answer, all of you. So in both the questions, sum of the radius is easy to construct. Pi r1 square plus pi r2 square is equal to whatever area is given, whatever sum of the areas is given to you. When the two circles touch externally, then the distance between their centers, is the sum of their radii, r1 plus r2. The distance between their centers is the sum of the radii. But when two circles touch each other internally, the distance between their centers is the difference of their radii. The bigger radius minus the smaller radius is equal to the distance between their centers. So there R1 plus R2 is the distance between their centers. Here, whichever is the bigger radius. So here R2 minus R1, the difference. R2 minus R1 is the distance between their centers. Okay, next one. You need to find the area of this region, children. This region. You need to find the area of this region. So what is ABCD? It's a quadrilateral, but give a special name to the quadrilateral ABCD.
Trapezium.
It's a trapezium. It's a trapezium. So what's the formula to find the area of a trapezium?
Half H A plus B.
Yeah, half into sum of the parallel sides into distance between them. So how much is AB? AB and CD are the parallel sides. AB and CD. How much is AB?
3.5.
3.5. And what about DC?
Ma'am, 2 plus X.
How much?
2 plus X, ma'am.
No.
Ma'am, 2 plus 3.5.
2 plus 3.5. Correct. Because what is BCEF? It's a quarter circle, right? BCEF is a quarter circle. So this is the center of the quarter circle, which means CE is the radius. BC is also the radius. This one is a quarter circle. This one is a quarter circle. So that means this is the radius. This one is also the radius. Quarter circle is a quadrant. Quarter circle is a quadrant. This one is a quarter circle. So what is this radius? What is this one? Radius. So this is the radius, BC, EC, radius. BC is given 3.5. This is 3.5. That means EC is also 3.5. And DE is 2. So 2 plus 3.5, 5.5 is DC. DC is 5.5. So we know the parallel sides. AB is given. AB is 3.5. DC is 3.5 because radius, this is the radius. This one is radius. And BC is given 3.5. So 3.5 plus DE, 2. This is 2. This is 3.5. So DC is 5.5. Sum of the parallel sides into distance between them. BC itself is a distance between them because it's a perpendicular distance. BC itself is the distance between the parallel sides, 3.5. So like that, you find the area of the trapezium. Then how will you find the area of the quarter circle? What's the formula?
A plus B by 2 into H.
Louder? Area
Sum
of
of
the
the
quarter circle formula. Oh, area of quarter circle formula. Quarter circle.
pi r squared by 4.
Pi r square divided by 4 or 1 by 4 into pi r square. So we can find, we have everything to find the area of the trapezium and the quarter circle. The difference, area of the trapezium minus the area of the quarter circle will be the area of the shaded region. Correct? All of you got it? Class use the emoji. Raise your hand.
Yes, ma'am.
Yeah. Sashank, Madhumita, Prajit, Raghavi, Krishmi, Rakshita, Navya. Why Rakshita is very quiet these days. Rakshita, Navya, Florentina, Arjun, Sri, Ranjan, Raja, Danya. Ritika is not there. Dileepan is not there. Very good. Got this, children? Any questions? Okay, no response. Fine, children, please complete this one. Please complete this. So before the next class, you'll have to complete the assignment. Whatever little you have to finish. You were working on the assignment today, the 7 sums. But if you had something more, a little more to finish, please finish that by the next class.
Yes, ma'am.
Yeah. So next class, mostly I'll give you an assignment on areas related to circle, the remaining sums. I told you I've already posted the answers to NCERT questions in the portal. So you can revise that by yourself. We've discussed most of the ideas in this chapter. So next class, I'll be starting with the heights and distances. Again, raise your hands. How many of you, lower your hands and raise your hands again. How many of you learned this chapter in school? Heights and distances. That is applications of trigonometry. Applications of trigonometry. Arjun has learned, Ranjan has not learned. Huh? Raja has not learned. Raja? Now everybody is raising. No, Navya has learned, then Raja. Okay, so, okay. Okay, so here all of us have learned. Yes, Sashank, you want to say something?
No, ma'am.
Okay. Fine, then it's easier to get into the chapter, meaning the creamy layer of the chapter, because all of you have an idea about the chapter. Okay, fine. Fine. So we'll next class we'll take up some very important questions from this chapter, heights and distances, or some applications of trigonometry. All right. All right, children. So Saturday's class will be offline also. It will also be at the center. So those who want to can come to the center. Anyways, see the message on Saturday. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you.
Thank you, ma'am.
Thank you, children. Good night.
Thank you, ma'am.
Thank you.